As Emma said, I'm a UI engineer. I work with State Street Bank. I'm not allowed to tell you much more than that, with it being a highly regulated financial firm, but yes, I've been working there just about 6 or 7 months. So a lot of kind of what I'm going to cover today is kind of birthed out of kind of some frustrations I've seen over the last while in the UI space, but in the financial sector. I worked probably the last 6 or 7 years working in fintech. For quite large-scale platforms, so think of like a website or a web app you come onto, lots of different business functions interacting with each other, lots of different application teams managing those little business functions, trying to bring them all together in a really nice, single, cohesive user experience where people can go on, things look the same, they look really nice, they're well branded with a company, but under the hood, there's kind of a bit of a mess there. You have all these kind of fragmented services, if you like. So we're going to look at kind of microservices today. We're going to look at it from probably more of the UI aspect in terms of micro front ends, what they are, where they come about, kind of what problem are they trying to solve. So for those that don't know, what are microservices? So microservices have been around for quite a long time. So it's basically a style of architecture that structures an application as a collection of small services that are highly maintainable and testable, loosely coupled, independently deployable, and organized around business capabilities. Sorry if I just forgot to say a timer on my phone. Cool. Okay, so that's basically what microservices are. So things, lots of little different components, all with a kind of single purpose, which is very important in microservices, but that they can kind of talk to each other. Okay, so why would I use microservices? So previously we built applications in a way it's now known as a monolith. So you kind of start off with a single code base, you take a little feature from here, another feature from there, another request comes in, you kind of bundle that in. It reminds me very much of, does anybody remember Buckaroo, the game? So you've kind of got the horse and you start hanging little things in and then eventually it just goes boom. So it's kind of like microservices try to address some of that and try to simplify things a little bit, although there is sort of additional complexity we'll look at later on. So fast forward a year or two, you can imagine you have kind of this monster monolithic project and you change one thing and the whole thing breaks. So yeah, the idea with microservices then is to focus on individual services that do one thing and do it really well. So moving on from microservices then, today the focus of this talk is kind of micro front ends, and this term came out probably a few years ago. And again, micro front ends, what are they trying to do? Well, they're trying to bring all the qualities of microservices, I guess, to the UI space. So they're highly maintainable and testable, loosely coupled, independently deployable, and organized around business capabilities. So those kind of core values. But there's an anti-pattern there, and that's what we're going to look at today. We're going to try and identify the problem, and then we're going to set out and actually just really giving you guys an understanding of how I've kind of run into that in the past, and then look at kind of breaking that problem down, how we could solve it, some technologies that are out there, and if we have time at the end, I'll do a little kind of live demo coding to kind of show you how I've kind of achieved some of what we've been trying to do. So yeah, I've already kind of mentioned then, so the trend with kind of UI development right now with Reacts, Angular, your views, is kind of like you take lots of these little components and within your project you develop them independently, which is fine, and then you have a build process which kind of gathers all these little components and then mashes them in and spits out kind of a single distributable file, which you then kind of upload and you release that, or maybe multiple files. But the idea is it's kind of taking all these little components, mashing them in together, and that is your kind of artifact that then you release, which, when you think about it, is a complete reverse of kind of what microservice architecture is trying to bring about. So in a typical microservice application, so we're not talking about micro front ends just yet, but in a microservice application, may look something like this. So you have 5 kind of microservices illustrated there, and at the top you have this kind of monolithic front end. So these could be 5 independent services doing lots of different things, talking to each other. But your UI is kind of one build because you use your Angular, you use your React, and your Vue, and you're getting kind of one single build. And it's kind of doing the talking to all these little microservices. But again, the quality of microservices is not brought through to the UI. Okay, so let's just kind of break that down a little bit further with some specific examples. So say I tasked you to build an application that had 3 core functions. I wanted a login component, a search component, and a file browser component. So you have 3, say, independent microservices. Very rarely would that ever be the case. There'd probably be multiple for each, but just for simplicity to kind of get the point across. But in the UI side, you have 3 UI components, but they're all in one single build. So again, you're kind of deploying one UI to do these 3 different things, but again, all your components are kind of on top of each other. So when you look at how that begins to scale, so you could have maybe a dozen or more different UI components there. Again, not necessarily all relational, one-to-one relational with microservice. It's probably multiple, but again, for simplicity, you still have that big monolithic front end. So scale this into like a financial institution where you maybe have 10, 12 different application teams all want to kind of pull content into a single UI experience. Then things begin to get very difficult. You're stumping each other's toes. You're kind of all relying on that kind of single build process to run smoothly. You're at each other's mercy. I want to release this weekend. No, I'm not ready to release this weekend. And unless you have a really clever Git branching strategy there, which can become quite complex, then you're going to run into difficulties. So just to illustrate, this is the kind of huge monolithic front end then that we are trying to break down this morning. So it's neither highly maintainable or testable, and again, it's not loosely coupled either because we're kind of trying to bring everything together. Okay, so let's look at the kind of build and release process of that. So again, you could have several different development teams working on these, maybe a combination of a development team working on 2 or 3 of these, whatever. Again, you still have to have that build process. So whatever you use to do your builds, you're still kind of at the mercy of each other. You're at some point, all that kind of components are going to have to merge. And again, how would that scale? So again, you have more different components. You're looking 2-3 years down the line, you're working a large-scale enterprise. Again, that build step, you have multiple components there, and it's definitely not independently deployable. And this is really the bit where the problem lies in the actual build. So let's kind of look today to see if we can reverse that anti-pattern. Let's try and solve that problem. So what if we could do this? What if we could each develop independently on a component, release that as a single entity? So we have a build step to actually build our code, and we're releasing a single artifact for each of these UI components. So this is introducing what micro-frontends essentially are. Okay, well, how would that scale? So here we're illustrating something slightly different where you have different development teams working on different, so these multiple components could represent an application, for instance. So here we have 3 applications within an enterprise organization, and again, there's 3 different build processes. So I've got 3 build pipelines here, if you like, which are producing an artifact each, which is then deployed as a micro front end. So how would that all fit in? So we have our kind of traditional microservices under the dotted line there, doing all the kind of back-end work, APIs, etc. And then what we have then above the dotted line is basically our UI tier. So we've got all our little UI micro front ends components. And then above that, we have what we're calling like a thin layer here to compose the micro front ends together. So we do want to kind of bring them together in a single cohesive UI experience. So for the user, as far as they're concerned, they're going on and seeing one web app or one website. The fact that there's loads of different application teams working on it is of no real interest to the user. But for the purposes of a releasing and deployment, if I wanted to release a change to my login microservice there, I could independently do that in terms of the UI and not impact the search or the storage or any of the other front-end microservices that are there. And I'm not at the mercy of their build process or their release process. I can release when I want to. And again, this thin layer, I've kind of straddled that across all the micro front ends, but the idea there, that in itself could be another UI microservice as well. It's kind of illustrated like that because it's the one that's kind of the rest of them we're going to feed into. We're going to look at this in a moment and how that would actually work or how that could work. So what were we trying to achieve with micro-frontends? Exactly the same as what microservices try to achieve: highly maintainable and testable, loosely coupled, independently deployable, and organized around business capabilities. Okay, so hopefully, conceptually, you get the problem. You get the problem we're trying to solve. We're trying to basically take that massive monolithic front end and build it into lots of different build steps and have lots of different kind of release processes there to actually get and compose our kind of micro front ends all together. So before we actually look at kind of what technologies, a bit of a disclaimer here. There's probably several ways to do this. Probably none of them are right, none of them are wrong. It really is down to you and what way you want to go about it. I'm going to kind of talk about some of my experience and how I went about that and how we've actually achieved this. But again, it's not necessarily the right way. And if we have time at the end, we will definitely have some questions. It'll be interesting to get some feedback from you guys on that, to see if maybe perhaps some people in this room have tried something a bit different. But again, with any kind of architectural decision you make, there's obviously always going to be trade-offs. In terms of micro front end stuff like build complexity, so now you just don't have one UI build, you could have multiple. Obviously that's harder to manage if you're looking at things from a kind of DevOpsy side. Performance, you could potentially have duplicate code, so you maybe have 4 or 5 different teams that are working in 4 or 5 different frameworks, or even the same frameworks, or different versions of the same frameworks, but they're all kind of releasing the same code. So from a user's point of view, in their browser, they could be pulling down a version of React, for instance, and another version of React, and a different micro front end, etc. So that's another thing to kind of consider as well. You have lots of different frameworks, you could have lots of different technologies in there that you might not have otherwise. Browser support as well. So I'm going to kind of verge a little bit into web components shortly as a kind of possible solution for this. There's limited support for web components as well. So if you're going back to some of the older browsers, the IE11s of the world, so that's another thing that needs to be considered. And I guess one of the kind of core things, if you are working in a kind of enterprise, is the look and feel is all important. So if you have a UX department, design department, they're probably not going to like this idea, because developers could potentially be pulling in different dependencies. Things could look a little bit different. So you really need to have really strong something like Angular material in there, or material design, or something that's going to kind of give you that consistent look and feel across all the different micro front ends. So going to look a little bit at web components now and what they actually give you. Web components have actually been about for ages. For various reasons, they haven't really got as much support, but in the last few years I'm finding, well, personally I'm finding a use for them in terms of this. But there are kind of lots of libraries now that are coming out of the woodwork now, or actually specializing in web components as well, and we'll have a look at those in a second. But web components are a set of web platform APIs that allow you to create custom, reusable, and encapsulated HTML tags to use in web pages and web apps. And then custom elements or custom components and widgets built on the web component standards will work across modern browsers and can be used with any JS library or framework that works with HTML. The nice thing about web components is that they are native. So it is extending upon your divs, all your kind of standard HTML elements that you will use on a daily basis. And there is good open source community support around web components right now. It's kind of been a buzz for the last couple of years. Again, it's kind of picking up a little bit of momentum. And these are some of the kind of libraries out there that are kind of specializing in web components. Stencil's quite a popular one at the minute. Angular Elements, which I'm going to look at in a short time. There's Polymer as well, which is another kind of popular one. Google's framework for kind of web components, and Slim.js as well, and there's loads more. There's tons of them out there at the minute. And again, the sole purpose of them is basically putting a framework around web components, but their output generally is a web component. Okay, so let's kind of bring some of that kind of thinking into our problem and see how we could potentially solve it. So you could, not saying it's necessarily the right thing to do, with micro front ends, you could technically have a team working in Angular, working on an Angular project, another team working on a React project, and another team working in a Vue project, and their output and their components are wrapped up as web components. So they're all kind of playing to the same roles, because web components is a standard, remember? It is in the HTML spec. So basically, their output here, so Angular actually do support web components, or are starting to support web components in the form of Angular elements. Now it's still in beta, so I think Angular 8 was released the other day. There is improved support for them, but again, I think it's not going to become official until Angular 9. React and web components kind of works together, but again, I believe kind of with React hooks and some of the more modern stuff in there, that there's improved support for web components as well, although they're not kind of shouting that from the rooftops. And Vue, I don't have as much experience in, but just kind of looking at a few POCs online, there is ways around and ways to do it. So the idea here is that you're kind of working all independently in your different projects. You're producing web components, which are essentially JavaScript, and then they are kind of released into some sort of container. So for the purposes of the demo, if I get time to do it, we're going to be using Kubernetes, we're going to be using Docker, we're going to have Nginx run inside Docker, which is essentially Nginx, a web server. It's going to serve a JavaScript file, and that's going to act as our micro front end. And we're going to have each one's going to have its own independent Docker container as well, which is going to be deployed into Kubernetes, and we'll have a look at that in a second. But again, just to assess, this is how things could potentially look. So we could have Vue in there, we could have Angular in there, we could have React in there as micro front ends, all working together. From a user's perspective, there's a single UI. And again, all nicely talking to our kind of traditional microservices. Okay, now for the fun bit. We'll go on, we'll do a little bit of coding here, and then if there's time at the end, we can kind of answer some questions. So this is what we're going to try to put together. So on the left-hand side here, or my left, my right, sorry, your left, we're going to have we're going to try and produce something like this. It's not pretty, I get it, but literally this is going to act as your kind of thin layer. And where it says Angular, that's going to be an Angular element wrapped up. So it's going to be developed from an Angular project. It's going to be released independently. It's going to be its own releasable artifact, and that's going to produce this. And then on the right-hand side there, it's going to have React as well. And again, we're going to talk to that from our so we're actually going to send events inside that. So that will kind of act as if that top thin layer is actually talking to micro front ends. And then back again the other way, we're going to let them talk as well, so that they can actually send information back to that kind of thin layer at the top. So again, some of the technologies there, with JavaScript in there and web components. We're going to use Angular and React as the two most popular frameworks for this POC. We're going to have Docker in there as well, and Helm is a release manager for Kubernetes as well. So it basically takes the Docker files and it does the release into the Kubernetes environment. For those that don't know what Kubernetes is, it's literally about kind of pulling all these little Docker containers together, and it's all about kind of managing them inside clusters as well. Okay, can you make that out down at the back? Can you see roughly what's going on there? So this is how we would go about, with inside an Angular project, this is how we would go about creating an Angular element, which is going to be our kind of view from the micro front end point of view. That's going to be the view that we're actually going to pull in to our kind of thin layer. So in the top left there, so we have our component. So this is just a standard Angular component. You can see the kind of just about there, you can see the inputs and outputs there. So this is Angular standard event binding. And we're just going to be, the actual web components are able to use that. So the Angular elements does the bit in the middle, where web components has its own kind of API, which we'll see a little bit in a minute. It basically maps that to the Angular event lifecycle, so we don't really need to worry too much. So this is literally just a standard Angular component, and we've got its name in there as an input, and we've got its event coming back out there as an output. And for the React one, again, this is a kind of standard React component there on the left-hand side. here we're doing a little bit of magic, and really all we're doing is, again, this is kind of something I pulled together, but there's probably much nicer ways of doing this. All this is really doing is taking React's native lifecycle hooks and it's mapping them to the web component ones as well. So just to give you an example, this is how we kind of achieved that in React. And the container application itself, so a little bit of, again, this is kind of thrown together. There's probably much nicer ways to do this. You could probably have a framework kind of managing this, but the sole purpose of this container is literally to take the other web components. So when we register, there's, as you can see there, there's kind of ngel is the Angular element that we are actually registering as a custom element in the browser, and within that custom element tag of ngel, we're going to basically inject our Angular component. Something similar being done there for React as well. Again, we basically identify the HTML element, and we kind of inject our web component in there. Okay, I'm just going to get in now. I'll just show you the code. Yep, so in here we've basically got, let's see if we can make that a bit bigger. So we've basically got a wrapper, which is, we've got a React component, and we've got our Angular component. So the first thing I'm going to do in here, okay, so the first thing I'm going to do is bring up the container application first. I can remember the make command I used. Okay. Okay, so if I give this a second, hopefully. Okay. So what I've literally done there is just bring up the micro front end, if you like, that's actually acting as the thin layer at the top, which is going to handle communications between all the components. But of course, Angular's brink and React's brink there. If we take a look at the HTML, inspect the element here, so we can see in here, there's an ngel tag, custom element tag there. It's very small down at the bottom. So obviously we haven't loaded in our React one yet, so it doesn't know about it. So that's kind of why those are blank right now. So the next thing I'm going to do is I'm going to spin up, go for React first. So I'm just basically showing here what services are currently running. So now we've just literally spun up the React one. So at the minute we have two in Kubernetes. We've got two servers there that are services, sorry, that are representing. One's representing the container and one's representing the React component. So if we go back to our app now and refresh this, so we now have React in there. And how that's actually loading that through then. So there is a JS file in there, and if we have a look, so I was talking earlier about the kind of independent release cycles and build processes. So really what you're releasing is just JavaScript. So that's literally how we're referencing our front end. And then the thin layer, as I say, is actually doing the important bit of actually bringing them together. How am I doing for time there?
You have 6 minutes.
Okay, cool. So as I begin to type this, you can see that it's actually sending the message from the thin layer, and it's actually sending it inside the component as well. So you can see how the messaging and the micro-frontends is working. It's all using the kind of web components spec for doing that as well. And if you keep an eye down at the bottom there, if I say hello, so you can see React says hello there. So what's actually happening there is there's an event being triggered inside our React micro-frontend, which has been brought forward into our kind of thin layer as well, and outputting the message. So what will be Angular then? So let's bring up the Angular service. So I'm just deploying that using Helm. Again, I'm just going to have a look now. So now we have 3 services. We have our container, we have our Angular and with React. Again, these are all independent, so they can be released independently. They can be brought up and brought down together. And now hopefully if I go back and refresh, so we now have our Angular component as well. Again, it's just brought in as a kind of JavaScript file in the front end. And now you can see that the name then has been passed to both Angular and React here. And Angular can say hello. So the event's been triggered from the Angular component, which is bubbling back up, and React as well. So for a few minutes.